Now we have Dr. Ramaraju. He is the group coordinator of R&D in the department of, now we call it Deity. It is Deity for us.
All of us are
Department of Electronics and IT, Ministry of Communications and IT. Anyway, that's what the title says, but he's a very multifaceted person. He's in charge of nano and electronics for the whole country. So he is monitoring many projects in this area, including what is going on in IAC and in IIT Bombay. Together, this is close to $70 million, which he is monitoring, which is. Then he is also involved in CDAC in a very large way. And then he is also the managing director of a thing called Media Lab Asia. This Media Lab Asia was started with certain intentions, and then the intentions changed, the partners changed, but the organization continues, and he is heading that. So he's again from, I want to say this in the sense, we requested people who are actually directly funding projects and who are looking at what are they looking for when you want to fund a project, as the people who wanted to come and participate in this particular set of lectures. So while he will not talk about if you have the following elements, I'll fund you, but you will see that theme running when he's talking about it. Am I right, sir?
Thank you, Professor Jamdagni. Thank you very much. Good afternoon to all of you. Good afternoon to all of you. In fact, Professor Jamdagni wanted me to talk on some of the initiatives on supercomputing. Probably, I think, so much has been already been said by Professor Balakrishnan, and I think probably I will not say so much of the supercomputing because what he said is essentially what I wanted to say also. But of course, however, some of the specifics I will talk about. And in fact, Professor Teenja gave us very good flavor of what kind of problems are awaiting for us to be solved by technologies. And in fact, I was very much excited to hear Professor Neeraj Suri. In fact, I will also reflect some of my comments from the department side. In fact, I am happy that you already spoken to our minister. And in fact, of course, I am sorry because some of slides I am using for my previous presentation, so they did show me something. I thought I'll give you a flavor of what presently we are looking at the Department of Electronics and IT. Of course, we are a department under the Ministry of IT, and this is the present this focus at the department. Of course, governance is one of the major activities, and industry. In fact, we are trying to see now, in fact, how to really support industry in India, especially in hardware, and we don't have so much of industry in hardware. And so far we have been able to do very well in IT services. But if you look at IT products and especially, of course, electronics products, I think we are very, we have to improve that. And we are trying to put up some mechanisms and also support industry in this endeavor. And innovation R&D, that's where I really do. That's one of the major focus themes for our department. And e-learning and e-security inclusion are some of the areas. I will especially focus on the innovation R&D. These are some of the areas which we are presently promoting, but there are about the areas. In fact, there is the area which we are doing, but they dynamically they change from time to time. And of course, from we have from communications to IT areas to electronics, and also e-learning, and especially India language. Technology is of course very much important, being we are having so many of course Indian languages, and of course I will not talk so much about that. And presently, personally I am a group coordinator for R&D in IT, and we have 3 groups in R&D at the Department of Electronics and IT. Of R&D IT is one group, and we have R&D in electronics, and we have R&D in broadband communications. And I am responsible for the promotion of R&D in IT. And there are some of the areas which I am responsible for and which I do. And of course, CDAC, I support CDAC, and that's one of my major contemplations that take major part of my time. And other interesting the activities, IT Research Academy, which we have recently established. In fact, that is, of course, in India, all of us know, though we are very good in IT services, Indian industry thriving, but still we feel we don't have, in fact, enough of the R&D capacity in India. I think some numbers always been spoken about, we have only about 50 PhDs coming in computer science, whereas USA is producing about thousands, and China is maybe 2,000 or so. And we have now specially taken focus to how to enhance some of the R&D capacities, and also all of us know, I mean, the R&D happens at some of the IITs and all the Institute of Science and some of the special research labs, but if you look at all the academic community, I think I think some of the most of the universities they don't have an R&D at all, and some of the universities they're very small research thing. And after ITRA is especially addressing to really how to create the themes, take up the some of the specific areas to start with. In of course ICT of areas, including IT, electronics, communication, and how to really build up the teams into that, so it will be able to create the critical mass of the organizations, also the researchers who are working in the specific areas. And ITR is also interestingly has the ability to really engage the international and Indian experts, from academia and industry, and that has a kind of flexibility to operate away from the government also. Probably that is of course one thing which I feel has the capability to really collaborate with the European this one. Of course I will also speak about something slightly later. Nanoelectronics is one of my areas which I spent a lot of time. In fact, was Jamdagini has mentioned. In fact, we started funding the academic R&D in a very big way recently. Previously, the R&D funding in a project used to be something like, I think, $500,000 maybe at the most. And in the Nanoelectronics, in fact, we brought Institute of Science and IIT Bombay together, and we started in 2005. And at that time we spent about something like about 100 crores. That's about 20 million US dollars. And in fact, one of the interesting elements there is about, I think, each of the institutes, I think about 40-50 faculty members are associated with the project, and about, I think, 100 students are associated with the project. And with this infrastructure has been utilized by, I think, almost 100 institutions in India. And in fact, we are able to train people, and we are able to engage them in R&D, and we are able to create some IP out of the infrastructure by the other organizations, across India through a program called INUP. There is the Indian Nanoelectronics Users Program, and some of the professors mentioned this is becoming like an example program. Probably it can be used to replicate into other areas also. We have activities like free and open source software and Bio-informatics. Historically, we have been funding at the number of organizations. In fact, we have some kind of critical mass in the bioinformatics, but of course DBT, there is Department of Biotechnology, also is funding, and we are trying to see how we can really combine with the DBT and try to see what kind of interesting problems we will be able to solve through this activity. And some perception based engineering is another area, to digging into largely to differently abled things, and also uneducated people, with some application, the e-learning and all of them. And digital preservation is another area which we have some programs, and we are also collaborating with some of the international organizations. And ubiquitous computing and green computing, there are some of things. And in fact, R&D policy framework is one thing which we brought out very recently to really think very comprehensively what kind of initiative we should take up in R&D. This one, we created a framework. In fact, our minister, we had a brainstorming recently. In fact, Professor Kincha was also one of the participants. I will just give a slide on the R&D framework, what we are trying to do. And we have a program for the of innovation promotion, intellectual property rights, and the policy. And the innovation promotion, we are trying to support incubations across India, of initially through academic organizations, and we encourage the startup companies through these incubation centers set up at various organizations. That's happening. In fact, we started about 20. We support about 27 organizations. I think 70 incubators have been supported to that program. Of course, in this year we are planning to improve it quite a lot. And intellectual property, we are also supporting some of the startup companies to really file the patents in India and abroad. We are also putting the bill, for them also, apart from the academic organizations. And I think, in fact, Professor Kincha asked me, when do we allow the the organizations which are developing the technology to own their IP. So in fact, Secretary has approved recently, and we should be notifying it probably in April. So that is something which we will be doing that. And in fact, EDA Lab Asia initially we set up with MIT USA, and and there we, in fact, I spent a lot of time, and that is where we do for while we develop technologies through various mechanisms, and we try to integrate some of the technologies to really address some of these societal problems, and also put into field deployment with some of the NGOs and some of the ministries into the healthcare, agriculture, different labeled of education. And I would also say, of course, we are not limited by these areas. Some of you mentioned, in fact, the big data problems. In fact, we are now thinking, which are the new areas we should really, of course, tackle, and we are, of course, very much open to, to include some of the areas. And I thought I will also talk about something about R&D framework. These are the some of things what we thought the strategies of R&D framework. In fact, how to identify some of thrust from time to time. Of course, all of us know in ICTE, you can't be static. In fact, every day things are changing. In fact, Professor Balakrishna said, you go, you have a shirt, and by the time you reach home, things are changing. So we are trying to really get into, how quickly we can really, be vibrating with that kind of speed. And you also said, I think one of you mentioned, what is the balance between the this fundamental research, only technologies and also getting into applications for a kind of political statements. And also, if I say that I am spending about $200 million a year, probably I have to show some result getting into field applications. And we also recognize strongly some of the underlying technologies are, of course, so much important. We are actually trying to see, what kind of this mix we can do. But there is also argument, because while you try to have an application, we always try to see there is really technology elements in the field. Otherwise, there is no R&D. Why we should engage all the intellectual powers to only do the application development itself? So definitely wanted to bring the application perspective and also basic technology perspective to that. And as I mentioned, enhancing the quality and quantity of R&D. There is a very much focus. At a department, we have apart from ITRA is one of the major programs for enhance the quality and quantity of R&D. Plus, separately we have a program to really create the few some few hundred PhDs in electronics and IT that is also being approved. And our focus is now, as compared to the Department of Science and Technology, Deity is always interested to industry and also product development. So from that perspective, our main focus will be always in the product development activity. And our focus will also be the entrepreneurship through promotion of the startups. As we already have some already established programs for incubation, and we are also creating some kind of there is a proposal for $2 billion proposal, but it's a scaled down, maybe something around I think maybe some $100 million. Yeah, no, is about I think $400 billion program. How to really support the entrepreneurships and startups and also establish companies to really develop the products in India by way of venture capital and also grantinites. Okay, and we protect the intellectual property rights and the patents. Yeah, they do in all the areas. Yes, MSME also some. Yeah, sure, sir. And sure.
The collaboration model between the academia, research institute, and the industry in India is almost non-existent.
Right.
So how do you involve the industrial interest so that they can come to academia to work in a common interest?
Sure.
Payment available from the government.
Sure. So in fact, actually, there are two schemes. One is that we have a scheme called MGS, that is called multiplier grant scheme. That is where we, if industry is spending 100 rupees, we put in 200 rupees. We provide a project to one of the, both industry and DIT give the money to one of the R&D academic organization. and the technology required for the industry can be developed by the institution, which can be exploited and which can be utilized by that one. That scheme is already existing. In fact, I have some projects pending in the sense, I'm under the process from Madras IIT. Yeah, he was also there in that one. That scheme is there, but I'm not saying that is enough of the scheme, and we are actually strengthening that scheme now, especially for industry. What I mentioned about, I think $400 million scheme, that essentially for that one, supporting industry across the board from end to end, starting from the startups to the established companies also.
Having said that, there was a program called Limitly, which supported actually with very low interest rates,
Yes.
kind of an interest-free loan. If I look back now, 7 years or 8 years of Limitly operation, for some reason it has not been yielding results that it should have.
Yeah.
In fact, we did not have a single case where something substantial happened.
Yeah.
So we'll have to debug. Your question is well taken. We'll have to debug and see what is it.
So actually there, some examples I know in the immediately, some industry startup companies have come up, they developed certain technologies, but their architecture is always an issue, requires some more monies. Probably we are also trying to support that one also, kind of initial architecture. Some companies in Bangalore, in fact, in the nanotechnology itself. The big
People have gone back to a mode of recovering the Limitly money, which is not the best thing. So that's why what you said is a problem. We'll have to debug that.
Yeah, sure. And the R&D infrastructure, in fact, in the sense we have to create certain kind of central facilities, of course, as a part of R&D. In fact, what we have created as at ISC Bangalore and also IIT Bombay, in fact, based on this, we also create across all IITs in Nano area. This infrastructure is can be accessed by the other academic the place and also by some of the industry also. And the human resources, in fact, we are trying to develop it quite a lot through some of the R&D programs, big project, increase the PhDs and also put in the people, and promote private-public partnership in R&D. Of course, has also asked me, in fact, there is some of the schemes we already have, and we also enhance the schemes. And the promote international collaboration. In fact, DIT historically we don't have so much of international collaboration in R&D. Of course, some of our organizations have, some of the projects have, but we are actually taking very specific steps now to improve the international collaborations through schemes like ITRE and also otherwise. This is where maybe we can also talk about that. The focus on the translation, there is a transfer technology and commercialization. The feeling across the board, while technology got developed various through so many products and everything, then the academic organization develop a technology, they go to other project, and the technology which got developed earlier will not be utilized. That can be so many reasons. In fact, the Indian industry may have been in a position to really exploit that, or sometimes we have to really understand the value of the technology at that point of the time. So we are trying to put up specific mechanisms. How to really pick up and also understand the value in each of the technologies, and also see what kind of measures can be done. These are some of the the initiatives. And in fact, I thought I will put a specific slide on the focus on the translation. Here we are trying to encourage the academia and R&D organization to file the patents before publication. This one, there's all of us aware of that. And technology transfer to industry, user agencies by academic and R&D organizations. We are actually trying to bring into focus on some of the technology development by creating some R&D portals, so that industry also they know that these kind of technologies are available. And not only that, also certain skills are available. I think some of you said, properly Professor Chincha has said, how to really make people are aware of that, what is available everywhere. We are actually trying to see what technologies and what skills are available, so that industry will be able to utilize these kind of things. And further development selected research results into technologies. In fact, sometimes always academic organization will do a technology, but then I think probably we are also trying to see how to engage other organizations like some the product development organizations to really pick up some of the the academic the results, and how to really bring into some products. And we are also trying to support the prototyping and pilot production for selected technologies. And we are also thinking about setting up a dedicated a special organization or institutional mechanism for promotion of technology transfer to industry. these are the kind of things what we are trying to do. That is about what generally we are trying to do at about IT. Because Professor Jamdagini asked me to talk about some supercomputing, but as Professor Balakrishna already spoken, but I will just say a few words on this one. Of course, all of us know that by November top 500 list of the supercomputing things. So I think India has I have 8 systems there. Some of the top systems for the 4th Dimension Institute, fourth paradigm of institute from Bangalore. That is a number 1 as of the November, and VSSC, ISRO Trivandrum, and a Central Research Lab from Tatas and IIT Madras. There are the some other one. Of course, in fact, all of us know as of November, Oak Ridge is a number 1 as of now. But at CDAC, in fact, I have let me come to that. Some of the user agencies presently which are involved in the supercomputing utilization, also some of the HPC systems available, some of the in-house development use, DRDO, BARC and NAL, ISRO, and there are number of education institutes are involved now. Of course, ISC will be driving this activity, and also there are other IITs and universities involved. And from the governmental side, while we are talking about the $1 billion supercomputing initiative, probably DST and DIT from government side will be major involved. We are trying to see what kind of role DST will play, what kind of role DIT will play, and then we will see what kind of articulation. In fact, Professor Balakrishna already mentioned that in fact, our organization CDAC has developed a supercomputer which is about 524 teraflops this peak, and is about 360.8 teraflop R max. This is now the number 1 in terms of the power in India. Of course, it could, if you go to November list, of course it was not developed by the time, but if you look at now as from the November list, it would be about 62 number if it is there, but you have to see actually when you come to this one, maybe May, June, where does it go? And I think probably one of the specialties of this system is a power consumption, because all of us are talking about the power. Probably this is one of the major attributes in terms of the power. It ranks at 33. We have spent about $3 million on this one. Include apart from the infrastructure already available. It can be used for various the applications. In fact, our CDAC systems are being utilized by the organizations across India, and also some of the international organizations from US and also other places. And Dr. Sat Babu, Dr. Prahlad Rao, they will be talking about that to some extent. I think some analysis of what is the present requirement of supercomputing as of now. It does not really see what the actual demand in the long run, but is only demand as of now, based on what people are, thinking to use at this point of time. So, this bioinformatics may be requiring a 2 petaflops and weather forecasting 1.5 and CFD some 1 petaflops and material science 1 and space 1 of others 3. Of course, I am sure, I think there is a lot of potential, actually hidden potential that will really would require a lot of demand. This some of the approaches, though it will be repetition a bit, but while we are trying to really build up the high performance systems, then merely having a high performance system may not mean really anything. So parallelly we wanted to really look at the applications and really design the hardware and see how it can really drive the whole thing from the application perspective. And of course also we wanted to go into collaborative approach for application development. We wanted to put a lot of emphasis on the focus on the application development. I think the application development organizations, the number of them, in fact CDAC will play very major role from the Department of IT, and we are trying to see how to really make all the organizations come together and to develop the applications. And also we thought we will be putting an approach for scalable architecture. While we develop a system, maybe today 1 petaflop, and it is really possible to really scale up as for the requirement. So we are also contemplating to go for some kind of scalable architecture while we prepare the hardware, and we'll also naturally will go for some kind of grid-based architectures for sharing of the resources. And fortunately, of course, as already mentioned by Professor Balakrishnan, we have the NKN National Knowledge Network. We intend to connect all the systems through NKN. The manpower development will have a special focus. In fact, we have some blueprints for the manpower development, and the exascale computing in the long run, though I think probably mean really will be developing a exascale computer, but we'll into the R&D of experts exascale computing, which will have so many other ramifications. That's another thing what we're thinking. There are some other applications what all we see, but I'm sure there will be so many other applications. I think as of now, as Professor Balakrishnan mentioned, there are some other applications which we are looking at this point of time, and we will be dealing with each of the applications very specific way. In the sense, now we are discussing between ISC and Department of Science, Technology and DBT and our organization CDAC. How to really put all the efforts into coordinate way so that we'll be able to maximize the impact. And as I mentioned, the effort will application perspective, and the important issue is the management issues of power and space and cooling while enhancing the computing power. So we have to, especially in India, we have to really deal with the power. So we have to see how to really that is also one of this one focus, and also the HPC aware manpower will be the important thing, I think. This again in architecture we are talking about how we were thinking about this only indicative. Some numbers may be similar to what Professor Balakrishnan said, maybe some numbers may be slightly different, but essentially how we are trying to do some of the large scale petascale systems, and some systems will be medium range, some 100 to 500 teraflops, and some of the small scale ones. So then we will be combining all of them through NKN. That is how we are planning to do. This is some what initially what we thought some of the systems of what we do maybe by 2013 we want to develop some 3 petaflops one system. Maybe we thought by going ultimately by 2016 maybe some kind of 20 petaflops system. What about actually what we want to do in exascale computing? Essentially from R&D perspective, there will be architecture, essentially one of the focus things, and new methodologies and technologies for designing applications, and adoption of applications for the exascale computing. Probably you have to redesign the software for exascale. Existing software sometimes are new software, and definitely power optimization will become this one key. These are some other things. In fact, I like to discuss in the sense how do we can go. We from the data side. In fact, you already spoken to our minister, and we are also specifically talking about international collaborations. We are open in terms of the collaboration in terms of IT and of electronics areas, and we have I think probably we have structure like ITRA, which can really become one of the enabling mechanisms between the collaborations, which can bring the Indian academia and Indian R&D institutions, and we can also talk about that during the day. Thank you for that.
Thank you very much.